Okay. So, okay. Yeah, should be fine now. Okay. So this is where we are yesterday. And now today we jump into the next topic, that is loops, loop control statements. Okay. This is another core topic. After this, we jump to data structures, and then after functions. Likewise,
I
we
think
keep
you're
going.
not sharing this.
No, I did that. Yeah, sure, I'm going to do that. Yeah, you can see here now. We just start with loops. Today, we start with the while and for. And we don't have do while in Python. Also, we don't have switch in Python like in other languages. So we have while and for, that's all. These are the straight loops. And while is the actual basic loop, and for is something like a special loop. So if you are from traditional languages like C, C++, Java, or all this, so simple. We have something like while similar to other languages, but for is a sophisticated loop which is applicable only on collections. So this is something where which only works with only collections. Anyhow, when we start working, you come to know about it with only collections. It is used to iterate collections, and this is something really useful while working in Python more than while most of the time you play with for, because we use a lot of data structures in Python, most because Python is something which is more applied on data. So in such cases, for is something which we keep using regularly, and while is something which is a traditional loop. Okay, like in C, C++ or Java, or if you are very new to Python, we are doing it from the very beginning. So you come to know how to work with any loop here. That is enough. So you don't need any background for any program. We are trying to cover each and every basic here. So that is fine. And we don't have switch like in C, C++, Java, or C Sharp or something. Instead of switch, we generally again use elif. Elif is something which can manage whatever we can do with switch in Python. So this is the idea. I hope you are clear. Now, let us start with while loops. What is a loop here? Loop is something which performs a repetitive task. So you know, right? Generally, loops, they do repetitive task until condition is false. So once condition is false, loop stops executing the loop. I mean, executing that thing. So that is the behavior of a loop. So now, while loop, what is while? This is any loop performs a repetitive task until that condition is false. Okay. So now, while loop. Let's start with while. So any loop performs a repetitive task. That's how, simply speaking. That is fine. Next one, the syntax of while look like this. And from then we jump to logic building there. We do a couple of programs, some 10 to 15 programs on while. That gives you a solid foundation about applying loops. And the syntax look like this, while some condition, okay, colon, and then you have some statements inside this. Okay. And then at the end, you should put some step statement. Of course, Step statement need not to be at the end. It can be anywhere, depends on your requirement. But generally, we keep it at the end. So this is a quick syntax of while. It's almost look like if statement. But the difference is if can check only one condition at a time. It cannot iterate. It is not a loop. But while is an iterative loop, it can check condition again and again until it is false. So this is a quick check, quick thing about while syntax and the what is there inside while all that. Now one quick thing we need to discuss is if you are working with any loop, we need to understand three things. Any loop needs initialization and condition and a step statement. These are important. Initialization means what? You should provide a start of the loop, where loop should start. But of course, we need a loop variable for that. But for any loop, at least for while loop, it needs all these three. What it needs, it needs initialization, it needs condition, it needs a step statement. Initialization means what? It is something where loop should start with what initial value loop should start. Okay, so this is one thing. Next one, condition. What is condition? Condition is something which says how many times loop should iterate. So this specifies how many times loop should iterate. And third thing, step statement, it increments a loop or decrements a loop. It depends on the how you want to iterate your loop. Suppose if you want to print 1 to 10, you should increment it. If you want to print 10 to 1, you should decrement it. So likewise, so if you want to increment or decrement a loop, right? Then any case, we need a step statement. Step statement means it is something which increment a loop or decrement a loop. That is a step statement. Suppose you want to print 1 to 10, then in this case, I need to increment. I should say something like depends on loop variable. If you make your loop variable I, it should be I equal to I plus 1. Or you want increment by 2. Then I should say I equal to I plus 2. This is a simple step statement, friends. Okay. Same thing you can rewrite it with the shorthand notation as well. It's up to you. But this is a quick idea. Any loop needs these three: an initialization, a condition, and a step statement. These are very important. The start point and how many times it should iterate, an incrementation or a decrementation. Suppose if you should, when should we decrement? I need to print 10 to 1. In this case, we have to decrement the loop. Okay, we can simply say I equal to something like I minus 1. If your loop variable is I, it is not like I should use I always. I can use X or Y or Z or anything, even a little meaningful variables names. This is a quick idea. Hope this is clear, right? So now what do we do? Let us start doing few programs. This is the while syntax, while condition statements and step statement. Before this, we have to do initialization. Let us do some programs. What are those programs? Program to print 1 to 10. This is a very basic program. Print 1 to 10 numbers. Okay, let's do it. So we do one thing. Decision making is completed. So what I do is I create a new Python package for loops. Sorry, I'm creating one more folder just to make sure. So I put it as a loops. So this is created and then Python file 1 to 10 test. So this is the simple program we are creating. So what is the first thing? Printing 1 to 10. So that is what. And initialization. Any loop needs initialization. So I take a loop variable as I and set it to 1. So that is initialization, where loop should start. And then second condition. So we are working with while here, 1 to 10, and then that too we are using while loop. So condition while, what is that? I less than or equal to 10. This is the condition what we need. Okay. Then just print that I inside loop and then increment I by 1. That's all. See, this is a simple loop where this helps us to print 1 to 10. You can see here, this is initialization where loop should start. This is condition, how many times loop should execute. Okay. See here, I less than or equal to 10. Until I becomes 10, we should keep on iterating loop. And incrementation, this is important. If you don't increment, your loop might fall into infinite loop. If you don't put this step statement, your loop falls into a state called infinite loop. This is important. So what happens now? It starts with 1, 1 less than or equal to 10 is true, comes inside the loop, prints 1, and then increments I. Maybe if you want to see the execution flow, put a debugger, and then what you do, right click and then debug this program. First, I'll do one thing. Let me run it without debugging, just run it normally. See here. Do you see 1 to 10 here? Perfect, right? Now after this, I'll do a quick debugging. So the execution started. Okay, see here. The debugger is at the loop. It is at the first iteration now. It is at to start first iteration. 1 is initialized. You can see values here. Then step over. And then it condition, first condition is true. So it gets into the loop. And then step over. It prints 1. And then step over. I got incremented. When I is incremented, you can see that the value of I got modified to 2 here in memory. In program, where you here you just see 1, but at memory level, your values keep changing. That change you can observe here. You got it right, friends. Again, step over means if you want to go check line by line, use this one. You can see here. This is just to execute program line by line. This control. And this control is something when you are calling a function, and if you want to get into a function, then use this. Okay, these two you can just use on and off. These are important for you. Now again, second condition will be true. Gets inside 2 less than or equal to 10 is true. Prints 2 and increments I. It becomes 3. And this continues till I becomes 10, friends. You can see here. Now I is 5, I is 6, I is 7, I is 8. Once I becomes 11, until 10, it keeps on. You can see there. Once I becomes 11, it stops execution. So this is programmed to print numbers from 1 to 10, friends. So I hope you understood this program. I'm just sharing the code, this very small code with you. Let me share this. Yeah. Okay, friends. Now the next program. You can see that you got it now. Now printing next program. You can take one more program. Maybe you can try this, friends, if you want. Printing 10 to 1 test. Try this, friends. Just take a minute and try this.
Just a moment. Why can't we use if here? Like even if also
Yes,
But
ma'am.
that is also one of the condition, right?
Yes, ma'am. But if you see here, if I put if, ma'am,
Hmm.
then so this what the actually what if does is if can check a condition only one time, madam.
Okay. Yeah.
Suppose if you put if and if you want to iterate as a loop, it's not possible, madam. Loop is like you are sitting in a giant wheel and
Hmm.
it keeps on iterating until that condition is false. But suppose I do the same thing. See here, ma'am. I'm trying to do the same thing. You can use if also, no problem. So now run this. You just get only one value. You don't get 10 values, ma'am. You know why? Because
Okay.
no matter whatever the condition is, it can check a condition only for one time. It is not a loop, ma'am. It is just a decision or a conditional statement where it can check it only for one time. It cannot check for until this condition is false. You got
Okay.
it, ma'am?
Yeah. Yeah.
So that's it. So next. So I hope this is clear. Next, you can see, let's go to the next program, print 10 to 1. Just quickly do this. Let us quickly solve few problems here. Printing 10 to 1. Okay. Print even numbers. Print evens from 1 to 10. Print odd from 1 to 10. And sum of first n numbers, first n natural numbers. Means at least you take first n natural numbers. Okay, at least 1 to 10, sum 1 to 10. If you know that, then it is same for doing sum of any numbers. And somebody asked me a few things. Like now, print factors of a number. Okay. And then sum of factors. Okay. And then perfect number. Okay. Count of factors. Okay. And then prime or composite. Okay. All this. Okay. If you can just solve this, at least you get some good exposure. Count of factors. Sorry. There is a typo here. Good exposure, friends. So this 1 or 2 sessions we dedicate for logic building. In this process, if you have any questions, we'll try to address them. Now let's start quickly with printing 10 to 1. Excuse me, 10 to 1. Okay, just you can start doing, friends. Don't wait for me. Just keep solving. If you have any issues, just ask me. How do you print it? This time we should start with 10, some I equal to 10. Again, a small advice or small suggestion for you is a small tip. As we practice with IJK all this year, please don't adapt to the same practice when you are working in your projects. You got it right, friends? Provide some meaningful names when you are doing looping, all that. That is important, friends. Okay. Like next one. While I greater than or equal to 1. Okay. This time you can see there is a slight change in condition. Now instead of using less than, I use greater because I should do decrementation because based on my requirement, I change even my comparison here. You can see here. This time I need greater, not less than to print 10 to 1. So I choose that now print I and then increment I equal to I plus 1. Now, sorry, this time if I increment, it won't work, friends. What is that I should do? I have to what? I should decrement this. This is as it is 10 to 1. It is a very simple thought process that we should decrement here. We should not increment, friends. So right click and then run this. And you can see here we have 10 to 1 here. If you want to debug, put a debugger and then run and then say debug and just go step by step. Then you understand what is the execution flow. I already clearly explained how to debug code. By now, you should become familiar with debugging as well. Okay, right, friends. So this is about printing 10 to 1. We keep on doing this debugging like throughout our course. But already we did that, so now I am not doing again. So this is the execution flow, friends. This is how we can create a simple loops to print values, to iterate over something. So this is the idea, friends. Okay, 10 to 1 is done. I think all of you also had completed. I'm just sharing this code base also with you. So now, what is it? Take this code, friends. Next one. What is next problem? Next problem is this one. Printing even numbers, friends. Next problem is print even numbers. 1 to 10. You can take up to how many ever you want. It's up to you, friends. I'm closing this here, also closing this. Generally, just close your windows to avoid unnecessary confusion. Okay, friends. Okay. So now, what is that I should do? Same thing, but this time you are you are enhancing it a bit. You are adding little more things to the loop now. It's not just a plain loop this time. Of course, we can do this in two approaches. So printing first thing is even numbers. Printing even numbers. And we can apply this in two approaches. What is that? One approach is just using loop alone. Okay. Second approach, adding a condition. So this is second approach inside a loop. This is second one. I hope this was clear, friends. So of course there will be many more. I'm showing you just two approaches or two ways of doing this. There might be multiple ways. If you can even work on those also, it's fine if it is available. So what is the first approach? Same thing we can follow. Sum I equal to 1 while I less than or equal to 10 colon print. Of course, here if you are depending completely on loop to print even numbers, this initialization we should set it to any even number. Put it to 0 or 2. It's up to you, friends. Okay, this if you want, you can read from keyboard. What is that? This comparison value. If you want, you can read from keyboard and pass here so that you can decide how many even numbers you want to print. You got it right. You can provide this as a dynamic initialization. It's up to you, friends. I have already shown you how to read value from keyboard. So print this I and then increment this. This time, if I want even numbers, this is a very simple thing. Set I to 0. We learn this concept from school days. Since school days, if you want even number, just increment by 2. That is the basic logic we apply. So I equal to I plus 2. So we are done. Now run this. See, we got all even numbers here. If you want till 100, just change this. So that if you do a dynamic initialization, you get how many ever you want to here, friends. Now run this and print it. See there? So that is the idea. Got it right? But some of you might ask a question. Manoram, I just want to assign I to 1. But still, I should be able to print even numbers. I don't want increment by 2, but I would be incrementing by 1. I want to add a condition check here. If number is even, then only I want to print it. It's not just like incrementing by 2. Then what do we do, Manoram? This is the question. Then we have to add a condition inside loop. This is more robust logic. This is just a very fundamental one, and this is much more robust one, strong one. What I mean is this is a strong one. So in such case, what do? We did this. I'm commenting this. I ran this right. This time this you can put this. You can see here. I am using triple quotes, multi-line comment. Okay. If you want just comment one line, put hash. These are comments what we have. Okay. So in Python, now what do we do? Same thing, set I to 1 while I less than or equal to. If you want to do a condition check and print values, I less than or equal to 10 colon. If I percentile 2 equal to, right, how to check a number is even or not, or odd. If number divides by 2, again, this is a school logic where we learned this from somewhere in our 3rd standard or 4th standard. If I percentile 2 equal to 0, okay, if it is even number, print the type. Print I only if it is even. Now you can see we are adding an if block inside while. We are slowly increasing the usage of constructs. While with if with while, and with more ifs inside while, more whiles inside while, likewise. And then increment loop. Where should I increment loop? Should I increment that inside if or outside if? If I increment inside if, there might be possibility we might run into infinite loop again. That's why, what do you do, friends? You can, what you can do, you have to do incrementation for while loop. If it is for while, that should be in if block, not in, sorry, that should be in while block, not in if block. So what do? I equal to I plus equal to 1. That's all. This time you can see I'm doing everything as a natural incrementation. I1 incrementing by 1, but still this produces even numbers to me from 1 to 10. Shall I run this now? I'm executing the program. You can see I'm able to print numbers from 1 to 10 because I introduced a proper condition in my loop. So that takes care of validating or checking if each number is even or not. If it is even number, it should print, else it should skip. So this is the idea, friends, printing even numbers. Got it right? Same thing you can apply for odd numbers, right? So I'm just sharing this code base again so that you can, let me share this with you. Okay. Following, friends? Yeah. Next, printing odd numbers. So how do you print odd numbers? Same thing, just a small condition change. So here, you know how to print even numbers. And if you want, you can quickly do a condition check here. I mean a debug. Set it to 1, that is fine. But still here, only thing you should do is either you can say you want only odd numbers not equal to 0. This is one thing. Or you can say equal to 1. Anything should be fine, friends. If you say I percentile 2 equal to 1, it's we are checking for odd number. Or otherwise not equal to 0, even in that case, we are checking for odd numbers. Anything should be fine. Now, if I just run it, you get odd numbers. You can see 1 to 9. Right? Suppose I am just showing you debugging, how this 2 condition checks happen. One for while and one for if here. It started with while. Now, if I say just step over, it comes to next line. Now it checks whether I is even or not. See here. Checks if I is divisible by 2 or not. Now run this again. So this divides I with 2. Definitely this is true because I is odd. Sorry, I should say if it is odd or not. Definitely I is an odd number and it is true. Then it prints value of I. Okay, and then increments. I becomes true. This time because we are validating for odd numbers, this condition will be false. Of course, see here. The loop doesn't enter into this block. I mean, it checks if condition check happens, but it won't enter into if block. See, it checks condition, but see, control jump directly again go to incrementation. See, it won't enter into this block because I is even number. This is for odd check. Similarly, step over, come to Y, and then do a condition check. Okay, prints this time 3 is even, or sorry, 3 is odd. Condition is true, prints that. This happens till like all values are printed. Okay, you can see that this keeps going. Yeah, finally we are almost there. See, and we got odd numbers here. And this is the execution flow, friends. You got it right. So that's all about what is that. This is how loop works in Python. So loops work in that too. While loop works in Python. So come here and then just
Out, sir. Sorry for
yes,
interrupting.
ma'am. Yeah, fine, no problem. Sharing the codes material. Yes, ma'am. You tell me. What's your doubt?
Can we have multiple conditions in the while,
Yes, ma'am. Why not?
like
Yes,
using
yes.
logical operators?
Correct. We can use multiple conditions. Depends on your need and necessity requirement. It's possible. Okay.
Okay.
You can. It's allowed. No problem with that. Okay. But it's all again need depends on your need and requirement. Understood? Yeah. Still, if you want to have more discussion on that, we can discuss this at the end of our session so that we don't break the flow of the topic. So yeah, but we can have it, ma'am. No problem at all. So next after that, so you can see there sum of first n numbers. New Python file. Sum of n numbers. You can close this. Suppose I want to find sum of first 10 numbers. So sum of n numbers. So then I should start with I1 while and take one variable, one result variable to set it to some initialization. Because we are doing sum, for that we need a variable to assign sum. So this time we have to declare a variable before while itself. Maybe instead of sum, you can say some result equal to 0. Not to get confused, sum is a built-in function. So I'm just taking result here. Or you can say some temp equal to 0, anything should be fine. And set that this variable, this resultant variable to 0. Why should I set it to 0? If I add anything with 0, that we don't have any change in the result. This doesn't change the result. That's why set it to 0. 0 plus 1, it gives you 1. So adding 0 to any value doesn't have any impact. But this acts as a filler. That is important. This helps us to start the performing sum of first 10 numbers. So take this variable to assign sum. And again, this looping is same now. I less than or equal to 10 colon this result equal to a result plus what is that I do? To this result variable add I. And again reassign that result into the result itself. And this should continue till all that, till the whole loop iterates. And this just gives you sum of first 10 numbers. This is the logic. Like people say sum equal to sum plus I, or result equal to result plus I, or x equal to x plus I, something, whatever it is, friends. So this is how you can find sum of first n numbers. I hope this is clear. Now print that. You can, in this case, you don't need to print result in the loop. Even if you print in loop, there is nothing harm. You don't have an issue, but you get incremental sum. You don't get total sum. In these kind of problems, printing your resultant variables outside loop is best practice. Maybe if you ask a cross question, like suppose what if I print in the loop, Manoram? Just print it. You get incremental sum. After every iteration, what is the value of that result that you get keep printing? So that is incremental sum, what we call. So what I do now, I increment my while. So I equal to I plus 1. See here. Okay. Now run this. Now you can see here. Every iterative sum you can see it start with 1. After that, 1 plus 2 is 3. 3 plus 3 is 6. 6 plus 4 is 10. 10 plus 5 is 15. 15 plus 6 is 21. 21 plus 7 is 28. 28 plus 8 is 36. 36 plus 9 is 45. 45 plus 10 is 55. This is incremental sum. In every iteration, right, we are doing sum, right? If you want to get this incremental sum or iterative sum, you can just print that loop, that resultant variable in the loop itself. Okay, friends. But in these kind of scenarios, printing your resultant variable outside loop is important. Okay, this is a good practice. So, okay, so you can just choose, okay, so you can just add the sum is the sum of n numbers is, excuse me, friends, colon. That's it. So, and then one thing I should do is close the string here. So still there is some error. Sorry, why error? Because I should remove this. Okay, no problem. This should
Yeah, yeah.
run this now. See, sum is 55. So when you are doing these kind of programs or logics, printing the result, whole result outside loop is best practice, friends. Again, we have seen another other way also. What if I print inside the loop? Nothing happens. But only thing is you can see that iterative sum or incremental sum. That's all. No harm in that. But when you are working on at a project level, yes, definitely these kind of logics we implement at project level as well. We need to do some uncertain things. Some or product is the frequent operation you keep on doing, because in data engineering also you keep on validating data. This sum is essential logic, the core logic, one of the core logics you do. Sum of all numbers in a list, all data in a list, or sum of some product of all data in a list. Something like you keep doing, friends. That keep happening. So this is one core logic. Please practice this, understand this. Definitely, this is very important, no doubt about that. So now I'm just sharing the code base with you. Practice it, friends.
Can we add starting number and ending number in print statement?
Why
The
not?
result.
Definitely. Yeah, definitely. You, that's all just adding a print. What is that? The start value.
No, in final print, the sum of
Ah,
number, the sum of 1 and
mhm.
10 and number is 55, like that.
You can add it. So you can do one thing. sum of numbers from, okay, 1 to 10. Or else, if you want dynamically add this, just read this from keyboard and pass it here. What is the start and what is the end? Do a dynamic initialization here, because this keeps changing. This at the end, this becomes 11. If I want to pass I here for 1 to 10. So the best practice here is, again, the best thing is try to input it from keyboard, sir. You got it right? Take one start variable and take some, end variable, and then just pass it here, or take something here, condition variable, and then just pass both here. Do you want me to show, or you can do it yourself, sir?
If you show, it will really help us.
Okay, no problem. Then I'm just changing my way. I code this start value equal to int of input of something. Okay, and then you can say some, you are comparing value, right? Just I'm just saying comp value, compare value equal to, again, because we can make it more. This is more of enhancing the same code. You can see here.
Yeah, get it. So now you are assigning those parameters into that print statement. In that one,
Correct,
you are
correct.
printing
Let
start
me
value.
correct. Yeah, that's true. So now what do you do? Instead of this, you just say here start, and instead of this here, sorry, instead of this here, instead of 10, put it here. Okay, and anywhere should I change? Yes, I should add this. I should, instead of I have to add like this. This looks much better, right? Instead of ij. Okay,
Yes.
so you see here now, you can pass start value, sir. Again, I think start keeps changing. I can do one thing. I do one thing. Temp equal to start value, so that even I change, the start changes. Instead, sorry, I think I'm saying I start changes, start value changes. Still, the start, the beginning value is preserved here. Oh, then I should do one thing instead of doing this, because again, I start keeps on changing. So there is something what we can do directly. We can do assign it in the beginning itself, so that even start value changes. The original value is preserved inside temp, that beginning value. So copy this temp and put it here. Copy this comp value and then here, put that here. Now you can run this code, and then it asks by default, if you want, you can add, enter start value, enter compare value, all that. So I didn't put that. When, if you don't use description here, make sure you pass two values here. Otherwise, you don't think that again there is some problem with your program. Program is perfectly fine. Only thing is, what is that you should do? You should pass two inputs, 1 and 10. And you can see sum of numbers from 1 to 10, at 55. Do you get it, sir?
Yeah. Thank you. Thank you so
So,
much.
and with all this change, you can see this, when I use IJ, it's more like a school kind of program. When I change that and made variable changes, you can see this looks more professional code. So that is the impact what we have when you provide meaningful names, friends. You got it right. But this is just an FYI. At this level, it's up to you. But giving you an FYI so that it helps you when you're doing development. So this is something, yes, this is a useful scenario. That's why I spent little time on this, so that this also enhance the way we code here, the way we think also. So thanks for the question as well. So let me just share this here. But one simple thing for all of you friends, these days, no, technically you should be good. One simple tip for all of you, when you want to get into coding, we have that fear, we have that, so many people think coding is difficult. Yes, definitely once upon a time, not now. We have many tools these days. It's not like you should be expert in programming. It's the confidence you need, sir or madam. You need that. So earlier we have to code everything on our own, but now with the emergence of AI, everything, coding become easier and easier every day. But only thing we need is that confidence. Yes, I can do this. And second thing, when there is a problem, it's the approach, how we solve it. That is important. It's not like suppose while we need while, you don't need to remember what is that while or how while works. But that basic understanding is important, is essential. Because if you know that, that's easy for you to search something anywhere and get that code and then integrate in your code and test it. To do all that, at least you should have that basic understanding. So that is where this teachings, learnings, all this helps you, friends. Okay, this is fine. We are done with sum of n numbers. Now next program. So what is it? So that is, we are done till this factors of a number. Somebody asked me about prime or composite tested. I'll show that as well today itself. Okay. How to find factors. If you know how to work with factors, then perfect count of factors, prime or composite, all this depends on just this factors thing. Means even for logic building, there is a kind of fundamental you need to get that. You got it right, friends? If you know, if you start with set something, you can get into something. That is a simple thing with logic. You got it right, friends. So what do you do right now? Come here. So we are trying to print factors. I know we don't spend too much of time on logic building, but whatever the foundation thing you need for thinking programming, that we definitely cover here in our sessions. If you want to have more additional coverage, stay back after class or you know, otherwise we can have some exclusive sessions for that. We are okay for that, no problem. Factors of a number. So now you take any number, maybe better read it some number equal to input number, you can say. You can add input number, read it from keyboard, convert it to integer. Okay. If you want, you can add enter input, but I'm avoiding that. You know why I'm not passing? Suppose if you go to hacker rank, I didn't try solving the Lee code, all that, but in hacker rank, they don't just pass something, enter something. So that this kind of practice helps you, if at all, if you do some problem solving in hacker rank. That's why I'm not adding that enter something, all that. But it's okay to have that. Okay. So now, what is factors? Printing factors. Simple. Suppose I have number 6. So how to find factors for 6? This is very simple. From 1 to that number, from 1 till that number. Check. I'm writing check. I'm giving a algorithm. Small pseudocode, not algorithm. So small pseudocode. Okay. From 1 to 6. From 1 to 6, what? Check. If each number, what is that? If each number divides 6, friends. Divides 6 and remainder is 0. So here we have to check for remainder. Okay, we have to check for remainder, not quotient. If it divides 6. If that number divides 6 completely, it's a factor. Else it's not a factor. It's very simple thing. For this, we don't need to do so much of this thing. Your mind has all the logic in you. If I ask 6, I think 22, we have 22 members in this session. All 22 can definitely come up with factors. What is that? We know 1 is a factor, 2 is a factor, 3 is a factor, 6 is a factor. I'm very sure all of you answered this. And your mind has logic. If you are able to tell these 4 numbers, writing code is simple, nothing. Because inbuilt, there is some thinking in your mind. That thinking you have to convert it to a program. That's all, friends. So what did you do in the mind? In the subconscious, we are just trying to see if 1 divides 6, if 2 divides 6, 3 divides 6, 4 divides 6. Even your mind thinks about that also. We know 4 doesn't divide. And it's a quick checking your subconscious is doing. That's all, friends. So now what do? Just start your this thing. I equal to 1. because this should be always 1, so I am setting it to 1. Or you can say start value for more this thing. Okay, and then while what I can do, start value less than or equal to, this time I should use what? Input number. Then if start value percentile, sorry, what is that I should do? I should see if 6 is that, not 6. If that input number is divisible from 1 to 6, we have to iterate through loop. And every time you should see 1 divides 6, 1 divides input number, 2 divides input number, 3 divides input number, 4 divides input number, until that number. If it is 6, 1 to 6. If it is 10, 1 to 10. So what do you do here? Input number divides start value equal to start value equal to 0. You can see. In this case, if it is divisible, just print what? Don't print input number. Print that start value. Okay. That's all. Or maybe more than start value, better put loop value. That makes more sense. Otherwise, it might confuse us. So I'm just making a quick change here. Print that whenever input number is divided by loop value, you should print that. That's all. And finally, what is that I should do? Increment loop value. Okay, loop equal to loop plus 1. Now this helps us to get factors of some number, friends. So when I run this, you can see 1, 6, 1, 2, 3, 6. And it expects a input here. I'm giving 6 here. You can see 1, 2, 3, 6. Suppose you run this, give some 100. You get factors of 100. See, these are all factors. By looking at them, you can easily confirm that these are factors of 6 here. Are you following, friends? So this is about finding factors. Understood? So I'm just sharing this code with you. And then we jump to next scenario. Sum of factors. When you do sum, then we are almost ready to check for perfect. When you do count, we are almost ready to check for prime. These are all very simple things. Okay, so let's do this. Let me just share this code base with you. So you can take this. Now you can do one thing now, count of factors now, or sum of factors. Sum of factors of a number. Okay, close this. Now what do you do? If you want, you can use the same thing, just a small change. Factors of a number, you can use the same code base. You can close this. You can choose any one of these two. So sum of n numbers, right? This you can remove that. Sum of factors, just add that here. Now what is that I should do? Take one. See, this is almost 90% of logic is completed. Here, what is this? Once you know how to print factors, count of factors or sum of factors, all that, all is just a matter of adding a small logic. And this itself is almost 90% done. And you know how to find sum of first n number. Sometime back we just discussed. If you remember this, applying this is so simple here. Just take one result variable and set it to 0. If you want to find sum of factors, I should mute someone. Let me just mute all. So this already we know, because we clearly discussed how to test this, right? How to print factors. To this, we just need to, if I want to find sum of factors, what is that? Every time this loop divides this number, every time this loop value divides that input number, then that is a factor. Then we just need to keep on adding such factors. So what do we do here? Here itself, we just add a simple logic, a conditional logic. When this sum should happen, this sum should happen only when that loop value divides input number, because only in that case it is a factor. So result equal to result plus loop value. Excuse me, friends. Okay. So this gives you sum of factors. When you know how to find sum of factors, doing perfect is very simple. When you know how to find count of factors, doing primary or composite very simple, right? You are almost working on the background for those two logics, right, friends? And finally, what this time? Where should I print this? Print. Okay, F. You can use as usual the format string F colon, and then the sum is okay, or sum of factors, maybe make factors is okay, and then just print your result here. To be more this thing, you can say sum of factors itself instead of result here. You can add something like sum of factors. Making more meaningful variable names is always a good thing in programming, because by looking at that variable, you understand what you are doing. This is also fine, friends. Okay, finally, copy this and add that here. Now, when you look at it, by looking at itself, you can get that this is something variable which has all the sum of factors. Okay, now run this now. Now this should give you what? 1 plus. I'm giving 6 as for testing. So test case, in the test case, what I'm doing here, I'm providing one my input value as 6. Now, what is the sum of factors of 6? 1 plus 2 plus 3 plus 6. Probably it should be 12. Yeah. So run this now. So give 6. This should not wait this much time. Why? We are converting it to input number.
I think it is going into infinite loop somewhere.
We are doing incrementation, right? So
We need to remove the print inside if condition.
that print don't have impact. It just try to print. That doesn't have a big issue. So anyhow, this is a chance to invalid literal value error. It's getting into the value error. Okay. So input number is fine. We are iterating till this input number. That is okay. It's staying comp value. Where is comp value? Okay. I think somewhere it's not picking up this. That's all. The issue program is perfectly fine. Some of this. We don't have this comp here. So probably, yeah, here you can see this, right? Why this issue is it is trying to import something. Probably this should be because of this. You got it, friends? So remove that there. While importing result, it by for some reason it got imported. Other than that, this code base don't have issue if I am not wrong. Let me run this. This time it should give you expected output. See, perfect. So why I ran into some issue? Because unknowingly some import happened there at the top of your code. That there it is importing result for somewhere, and that is why it is throwing some issue. This code base is perfectly fine. No, if you print inside, if that doesn't have a problem as long as you are properly incrementing loop. This code is perfectly working code. No problem with this. See, you print all 4 factors and you can see the sum of factors here. All of you are following, friends. So this is test case 1. Suppose if you give another test case, you get the same output. I mean, suppose you give some 100, sum of factors of 100. Now run this. If not 100, you can give any value of your choice, friends. You can see here, we are printing factors also, we are getting sum as well. You can see here. Got it right, friends? 217. So that's all. This is idea about sum of factors. Right? If you understand this, then you can work on one more logic, perfect number. So same thing, perfect number is a bit of extension to this. Means for perfect number, you almost implemented 90%, 95% of the logic. We'll talk about it again as a separate program more than this. Right? So that it's easy for you to get the logic. So just test it now. Next after this. What is it, friends? Perfect number. So I think you are good with this, right, friends? We had very clear discussion on this, how to implement sum of factors of a number. So then we have to check on perfect numbers. So what do we do right now? Right click and say new Python file, perfect number. So same thing you can copy and paste here. Right? Is that okay for you? Because we had a detailed discussion on this, so I'm copying and pasting. Is that okay for all of you, friends? Okay, come here, paste it here. Still, if you have any issue, just you can ask me after class, no problem. So how to find perfect number? Perfect number is simple, friends. This is perfect number. Sum of factors. Already we did sum of factors, you know that. Sum of factors of a number excluding, you should exclude factor of itself. If you don't exclude, never ever you get a perfect number. While doing sum of factors, don't include that number. Even every number is a factor of itself. We know this by notion, but just exclude that number alone. Self factor you exclude, simply speaking. Exclude self factor and add sum of all other factors. Excluding, I just make it simple, self factor. E is equal to what, friends? To the number itself, or to that input value variable itself, or value to the number itself. This is perfect number. Best example, just for instance, you take 6. Exclude 6 and try to add remaining factors, 1 plus 2 plus 3. What is it, friends? 6, right? Sum of factors excluding self factor is nothing but 6. Then this 6 is a perfect number. Likewise, you can check for multiple numbers, if it is a perfect or not. You got it right, friends. Then we are almost done with the logic here. Whatever code we are writing here, this covers almost 95% of the logic. The only thing is we should do a condition check. What is that, friends? A small condition check. What is that? If your actual number, as per definition of perfect number, what is that? We have to do a simple validation on this. What is that validation? If your sum of factors and if your input number, if both are same or not. That's all. That is the only thing I should do. What is that? If input number is equal to what? Sum of factors. And here I should, okay, while iterating small thing, you should don't exclude or avoid saying equal. When I say less than, loop value less than input number, it won't try to include that self factor. Means we are trying to iterate loop if suppose you are giving 6. We iterate loop till what? Loop value till 5. Once it becomes 6, we should skip that. Means we are not including 6 in the comparison. So with the first 5 values, we are fine. If it is if input when number is 6, once it becomes 6, we should that condition should be false. So this is the idea. So if you just remove that equal, that does this almost whatever that is needed. Then you can directly do this validation. What is that? If input number equal sum of factors colon, then you can say print what is it? F, of course, F colon that just not F colon, sorry, F quotes start that input number is a perfect number. You got it, friends? And then close this. So this is the idea. That's all. Else, you can add else part as well. Colon, print. Sorry, friends. He is not a perfect number. So now you can run this. This is one way. The other way is you can still have equal and then just do minus from the sum of factors, that input number. I'll show you that as well once I run this. Okay, are you following, friends? Okay, see this. This is all about perfect number. See, just give some 6. Definitely 6 is a perfect number because sum of factors of 6 excluding self factor is just 6 itself. Suppose I give some 9. 9, you can see 9 is not a perfect number because sum of factors of 6 excluding 9 is just 4. You got it right? So that's it, friends. This is perfectly validating if it is a perfect or not. You can see here I did less, I just removed less than or equal. Suppose you do sum of all factors and still you want to validate same thing. Then in this case, the sum of factors also have sum of self factors. So you should just do minus here. In that case, simple do the check is remove that factor, whatever you did sum, do a minus of that factor. And even this is also fine. If you don't want to change anything in the code while doing comparison, just subtract that input value, that actual number from the sum. If you are doing this sum of all factors, including self factor. This is another way. Now run this and just give 6 here. And still you get the same output without any impact. But the first approach is the more efficient than this because again it has to do one more additional operation. Performance wise, this is a bit degrading. And generally when you are working on programming, of course I am not doing that. You should adapt to that in a day or two, but keep thinking in terms of performance as well. When you are running a code, see how much performance it is giving and how to optimize that performance. Always that should be your end goal because tomorrow if you become an architect or if you become some other solution architect, our end goal is more than writing code or anything. Optimizing the utilization of resources is what an architect or some senior level people think. So just keep adapting to that kind of practices. That's all, friends. This is idea about what finding factors. I'm just sharing this and sum of factors, all that. Sharing this code base with you. I hope you had some interesting logic session today. This should help you keep practicing. Any help needed, you can always reach out to us. So we help you. So this is for today. So tomorrow we are end of this core logics. Tomorrow I just complete count and prime and then jump to another topic. Okay. So I'll also start with for possible, if possible, tomorrow itself. So not tomorrow, sorry. We catch up on Monday. Is that right, Siva
Yes,
sir?
yes, sir. Yes, sir. Yes, sir.
Okay.
You can
So
continue.
Yeah,
we try.
I have